the first topic, that is number system. We are going to do the revision. Okay, so in each and every class, I'll be taking one of the topic, one of the chapter, we'll be finishing it. Like, we'll be discussing all the important concept related to that, we'll be discussing all the important questions related to that. So today I am going to take number system. Next class, hopefully today we will be able to finish it also. A quick revision we will do of all the important concepts. Okay, in the next class, like that only, I'll be taking the next topic and we'll be covering it fast, as the syllabus is already completed, and we are just doing the revision. Now we are doing the revision from the very beginning, which will help you when you will give the final exam. Okay.
Okay, ma'am.
Okay, so I'm taking number system today. So the first concept over here is how to write the numbers. Like, we have to write, let's say we have to write 5 rational number in between, let's say 1 and 2. So this is the first concept we are having over here. Okay, writing rational number. What is rational number? The number which can be written in the form of p by q, where the denominator q must not be 0. Yes, Ifra, today I was about to take the question which I had given in the last class, but since nobody was joining, I just started with the revision. We are going to start a series. I'll be taking that question, but since I have just started, we are starting the revision of each and every chapter. Okay, in one class, I'll be taking one chapter. We will be discussing all the important concepts related to that, all the important questions related to that. Then we will be moving to the next chapter. This way, we will be doing the revision of each and every chapter, which will help you when you are going to give the final exam. Okay. Okay. And yes, regarding circle, I'll be taking that in the next class. Let's do it quickly. So the first very basic concept over here is rational number. You must know rational number can be written in the form of p by q. Okay, p by q, where p and q both are integers. Now, what is integer? Integer we can represent on the number line. The numbers which you use to represent, that is 0. Here positive numbers, positive 1, positive 2, positive 3. Here negative number, negative 1, negative 2, negative 3. These are integers. Okay, so rational numbers are number which can be written in the form of p by q, where p and q are integer, and the denominator must not be 0. In mathematics, if we are having any fraction, the denominator should not be 0. 0 in the denominator, that means it is not defined, or that is not acceptable in mathematics. Okay, so that's why we say whenever we define rational number, the denominator q must not be 0. So that is rational number. Now the first very basic concept related to rational number was writing few rational number, let's say 5 rational number in between 1 and 2. You already know the concept. One of the method is to apply the middle term method. That is, let's say we are having 1 and 2 like this. Let's say we are having 1 and 2 like this, and then we can use the formula of a plus b by 2, that is 1 plus 2 by 2, and then we can get the middle number. Now we can go ahead and we can find the middle of this one. That is the longer process. And the shorter one was, if we are having 1 and 2 and we have to write 5 rational number, so we will be taking 5 plus 1, that is 6. And now we want to make this one denominator as a 6. Okay, here the denominator is also 1, so numerator will also be 6. This 2, I want to make the denominator as a 6. Yeah. So it was 1, denominator was 1, we made it 6, the numerator also we need to change, so it will be 12. Now we can write 5 rational number which can be written as, the first rational number is 6 by 6, the last rational number is 12 by 6. In between these two we need to write the 5 rational number, so we can write it as a 7 by 6, 8 by 6, 9 by 6, 10 by 6, 11 by 6, like this. Do you know this process? Both of you, do you know it? Ifra, Rumaisha, do let me know.
Yes, ma'am.
Rumaisha, do you know that?
Yes, ma'am.
Let's move ahead. So this was the first concept. The second one was, now you should also know that every, like, let me write the sequence. So basically we are having a a diagram like this. Natural number, whole number, integers, rational number. ध्यान से समझो, okay? Natural numbers, like here from this Venn diagram you can see that what are rational number. So natural number, whole number, integer, everything is rational number. You can see in the diagram also, if I'm talking about rational number, the bigger circle is the rational number. That means it will contain everything. It will contain natural number, it will contain whole number, it will contain integer. Now the next bigger circle is integer. So if I'm talking about integer, so whole numbers are also integers, natural numbers are also integers. Okay. Now the next, if we will go inside, the next circle is whole number. So all the natural numbers are whole number. Is it clear to you? Are you getting it? How I am moving ahead? I am moving ahead like this. Okay. First, we will focus on this rational number. We will focus on this bigger circle, the bigger one, the biggest one, the outside one. Now we can see the outside one is containing everything: integers, whole number, natural number. So we can say all the integers are rational number, all the whole numbers are rational number, all the natural numbers are rational number. Is it clear so far? Is
Yes,
it
ma'am.
clear? Similarly, we can say now we will focus on this circle. We can say we will focus on integers. So we can say all the whole numbers are inside the integers. So yes, all the whole numbers are integers. Now natural number, all the natural number are integer or not? Yes, all the natural numbers are integers because you can see it is just lying inside the integers. Okay. Similarly, you can say all the natural numbers are whole number. If you will just visualize this figure, then you will never ever get confused that why we are saying all the whole number as a rational number, why we are saying all the natural number as a rational number. Okay. So one thing, the first thing you need to know this diagram, and the another thing you also need to know the concept that rational number means what? Anything in the form of p by q. P is an integer, q is an integer. So yes, all the integers are all in. We will take any integer and we will be able to represent it in the form of p by q. We will take any whole number. We will take any whole number. Let's say we will take any whole number, that is 2, and we will be able to represent it in the form of p by q. That is 2 by 1 we can write, and that is a rational number. Okay, so this type of fill in the blanks true false question is also there in the first exercise. I believe this one is also clear to you. Okay, can we move ahead? Can we move ahead? Let me know.
Yes, ma'am.
Okay, now the next exercise is having the concept related to how to represent, uh, yeah, how to represent the irrational numbers on the number line. So first thing first, what is irrational number? So irrational numbers are number which is like the number for, let me explain the whole thing. So we are having decimal number, two types of decimal number we are having. One is terminating decimal, another is non-terminating decimal number. What is the example of terminating decimal number? So terminating decimal number can look like this one: 1.25, 3.567, 7.893. This type of decimal number is called terminating decimal number. That means it is at one point it will get stopped. Termination is there. Okay. Non-terminating means it will not get terminated. It will just keep on 5 like this. It will not stop. Okay. This is also one of the example of non-terminating decimal number. Another example of non-terminating decimal number can be 3.141567238 dot. Okay. So that is non-terminating, never ever stopping. Okay. Now this non-terminating decimal number is having two types: recurring decimal and non-recurring. So recurring decimal number is the decimal number where it will reoccur, where you will be able to see the pattern. Let's say the example is 3.25. So this is the example of recurring decimal number. Recurring means it will 25, 25, 25, 25, 25. 25 is reoccurring. Continuously it is following the pattern. Non-recurring means it will not reoccur. A very random number you will keep on getting, like 4.171325829384729624. No pattern will be there, and the decimal number will keep on going, keep on going, keep on going. None recurring. Nothing is reoccurring. Okay. So this is the this type of decimal numbers we are having. Now which is called rational, which is called irrational, let me tell you. This terminating decimal number is called rational number. Non-terminating is having two types: recurring, non-recurring. This recurring is called rational numbers. This non-recurring is called irrational number. So what is irrational number? Irrational numbers are the decimal number which will not follow any pattern. It will just keep on going, keep on going, keep on going, and will not follow any pattern. A very random number will just keep on coming, and there will be no pattern. Pattern means certain number will not keep on repeating itself. That's called non-recurring, non-terminating decimal number. Okay. And irrational numbers are those numbers. So whenever you will be having a square root number, a number which is not a perfect square, let's say root 2, root 3, root 5, root 7, okay, root 6, root 8. Okay, this type of numbers which are not a perfect square number, when you will find it, maybe the calculator will give certain decimal values because there is a restriction is in the calculator also. But manually if you will do by long division method, you will find that the decimal number is just keep on going, keep on going, keep on going, and it is not following any pattern. That's why we call these numbers as irrational numbers. Okay. So these are irrational number. Apart from these, pi is also irrational number. Why we say pi is a irrational number? Because the value of pi, however you take it as a 22/7, this is not the accurate value. Okay, this is just the approximate value of pi. Okay, we approximately we say it is 22/7, but it is not a rational number. It is irrational number. Why? Because when you exactly in reality, pi value is 3.14 something something something. A very random number will keep on coming, keep on coming, keep on coming, keep on coming, never ever is stopping. Okay, that's why we say pi is a irrational number. So the next exercise is completely related to irrational number. Apart from this, there is one more concept, that is representing the irrational number on the number line. Is that clear to both of you? Like how to represent irrational number on the number line? Do you know that process, both of you?
Yes, ma'am.
Okay, so the construction part I'm not touching. Let's move to the next concept. Now finding the decimal expansion of a number like 10 by 3, 7 by 8, or let's say 1 by 7, just find the decimal expansion, do the division, and after doing the division, look at the answer and tell that whether it is a irrational number or rational number. Yeah, let me check. No, we just have to do the division. Of course, these are rational number because here you can see p by q form is there. So yeah, this is the next concept which is given in the exercise. Here, what you have to do, you have to just write the divisor and remainder, nothing else. Now, the next concept is writing 1.27 in the form of P by Q. Writing 1.27, this type of number, which is where this is non-terminating. You can see 272727272727. It will keep on coming. So this is non-terminating, not stopping, and this is a recurring where you can see 272727. It is reoccurring, non-terminating. What is the type of this decimal number? The type of this decimal number is non-terminating. Recurring, you can understand it just by the name reoccurring. Okay, decimal number. Okay, so yeah, the question is, we have to represent it in the form of p by q. So what we used to do, first thing first, we used to take the given number as a x is equals to 1.27 27 27, continuing the pattern. Now here, how many numbers, how many digits are repeating itself? So we can see two digits are there after the decimal, that is repeating itself. So we will be multiplying by 100 over here and 100 on the other side also. So we will be getting 127.2727. Now what we used to do, we used to do the subtraction. Equation 2 minus equation 1. So we will be getting 99x over here is equals to 127.272727 minus 1.2727. So we will be getting 126.272727 will be 000. So here we will be having x is equals to 126 over 99. Right? Do you know this process? Do you know it?
Yes, ma'am.
This was also one of the concept. And the next concept was about the rationalization. So let me take few questions from there also. Rationalize 1 over 2 plus root 3. So whenever we have to rationalize any term like this, what we can do, whatever is there in the denominator, if in the denominator you are having a plus b kind of pattern, you can multiply numerator and denominator with a minus b. And if in the denominator you are having a minus b type of structure, you can multiply in the numerator and denominator with a plus b, so that we will get, here we will be multiplying 2 minus root 3. Why we did so? So that here it is a plus b and here we got a minus b. Now we can get the formula a plus b into a minus b, that is a square minus b square in the denominator, and we can write it in this way. 2 minus root 3 in the numerator 1 into this will be 2 minus root 3, and denominator a plus b into a minus b will be a square minus b square. Once we will use just do the squaring in the denominator, it will be 4 minus 3, 2 minus root 3 in the numerator, we will be having 2 minus root 3 by 1, that is 2 minus root 3. Why we did so? So there is a rule in mathematics that we don't leave square root sign in the denominator. Whenever we see square root sign in the denominator, we try to remove that by doing anything. So if we are having, let's say we are having 1 by root 2. So this root 2 in the denominator, we don't leave our answer like that. Whenever we get such answer, what we try? We try to remove the square root sign from the denominator. How can we do so? So for this question, we can multiply root 2 in the numerator, root 2 in the denominator. So basically numerator root 2, in the numerator is square root sign is well and good, but in denominator we don't want any root sign. So that's why we have multiplied with root 2, so that root 2 into root 2 in the denominator became only 2. Now if you are not sure why we are getting only 2 in the denominator, how come root 2 into root 2 became only 2? So it became only 2 when we are having root 2 into root 2. Like both the number came inside one root sign. Okay, they just collaborated and they are just going to sit in one square root sign. Now they made the pair and hence we got only 2. Okay, that's why we say root 5 into root 5, only 5. Root 6 into root 6, only 6. Root 7 into root 7, only 7. Okay, so we were having 1 by root 2. We did the multiplication of root 2 in the numerator, root 2 in the denominator, and our answer is root 2 by only 2. What I said? I said in numerator root sign is okay, but in denominator we don't want any square root sign. Okay. So this was also one of the concept over here where we used to do the rationalization, and now there was a exponent rule. So let's do that also. So the last, can you tell me if we are having 1 by 3 to the power 3 and whole is having power 7, how can we write? Anyone from here? Anyone? How can we apply the rule of exponent over here? Or if we are having another question as a 11 to the power 1 by 2 over 11 to the power 1 by 4, how can we go ahead? Anyone? Rumaisha, Ifra?
Ma'am, for 11, we can take the 11 common, and 1 by 2 minus 1 by 4 we can.
Yeah. 1 by 2, perfect. 1 by 2 minus 1 by 4 will be, let me know, 1 by 2 minus 1 by 4 will be, yes.
Ma'am, 0.25.
Uh, okay, you have converted it in decimal. In fractional form, if we will write, The LCM will be 4. Here we will be having 2 minus 1. That is 11 to the power 1 by 4, right? Right?
Yes, ma'am.
This way we can leave our answer. Okay. And if you want to write the decimal form, that is also okay. 11 to the power whatever you said, 0.25. And we can also leave 11 to the power 1 by 4. Now, what about the first one? 1 by 3 to the power 3 and whole is having power 7. How can we just open the bracket? Let me know. How can we proceed over here? Any idea? We can open the bracket and we can distribute the power because we know the rule of exponent is there which says that a to the power m and whole is having power n can be written as a to the power m into n. Okay, so here also we can say this 7 power belongs to 1, this 7 power belongs to this also. So we can say it is 1 to the power 7 over 3 to the power 3 and whole is having power 7, which can be written as 1 to the power anything is just 1, but the denominator it will be 3 to the power 7 3 times 21. Okay, this will be our answer. Is it okay?
Yes, ma'am.
If we are having 125 that is having power one, negative 1 by 3, how can we proceed from here?
Ma'am, we have to cube the 125.
Okay, so we can write 125 as a 5 cube.
Yes, ma'am. 5 cube.
So now what can be done?
Ma'am, we have to multiply the power 3 with minus 1 by 3.
So we can write it as a 3 into negative 1 by 3. So it will be 5 to the power minus 1. Is it the answer? Is it the answer?
Yes, ma'am.
We don't leave our answer in the form of negative exponent. Is there any rule which will help us? Whenever the
Ma'am,
negative exponent is there, we have to do something.
ma'am, 1 by AM formula.
Yeah. 1 by 5 to the power 1. Yes or no? Basically, the formula says whenever you are having a to the power minus m can be written as 1 by a to the power m. Right?
Yes, ma'am.
So the formula says whenever you are switching the place, if you are making any like numbers, if you are just keep, let me give one example. So let's say you are having 1 by 2 to the power negative 2. So we have to switch the place, we have to shift this 2 to the power minus 2. It is in the denominator. If we will write it in the numerator with the multiplication of 1, the power will reverse its sign. Previously it was negative. When we have changed the place, it became positive. The power became positive. Remaining rest of the thing is as it is. Okay. So basically the rule, the exponent rule says whenever we are switching the place from numerator to denominator or from denominator to numerator, if the power is negative, it will become positive. If the power is positive, it will become negative. Okay, so whenever we will be switching the place, let's say I am having 8 to the power 5. The power is positive. It is already in the numerator. Why I am saying numerator? Because nothing is there in the denominator. That means 1 is there. So when we will reverse its place, it will be 1 by 8 to the power minus 5. So whenever you will switch the place of any number from numerator to denominator or from denominator to numerator, the power will reverse its sign. Okay, that is exactly the rule. Like that's the meaning of the rule, that a to the power minus m will become 1 by a to the power m. This total thing which was in the numerator at first, I have shifted it to denominator, and hence the power reverse its sign. It was negative, it became positive. If it will be already positive and if you are reversing, then power will become negative. Got this formula? Is it clear now?
Yes, ma'am.
So yeah, I can see we have covered the whole. Quickly, we have covered all the important concepts from here. Now, if you are having any doubt from here, please do ask. I'll be taking your doubt now. Please do ask any doubt if you are having from the first chapter, that is number system. No doubt?
No, ma'am.
Numaisha, Ifra, any doubt?
No, ma'am.
Do practice each and every question from this exercise, and in the next class also do let me know if you are having any doubt from here or not. Okay, now the question which I have given in the previous class, let me take that. Ifra, you was there in the previous class, no? Ifra,
Yes, yes, ma'am.
I have given one question. Have you tried that question? Yes or no?
No, ma'am.
Let me take that question. Okay, so the question was, there is a circular path. Radius of this circular path is 20 meter. And this circular park is situated in a colony. Three boys, Ankur, Sayed, and David. Three boys are there. Let's say Ankur, Sayed, and David. These are the three boys are sitting at equal distance on its boundary. So you can see these three boys are sitting at equal distance, and they are sitting on the boundary of the circular path. So we can say the distance, this as, like we can say this is a, this is s, this is d. So as distance, sd distance, and ad distance all are same. As, sd, and AD, all the distances are same, which is given in the question itself, that they are sitting at equal distance from each other, and also they are sitting on the boundary of the circular path. Okay, what we have to find? They are also having a toy telephone in his hand. Each and every boy is having toy telephone in their hand, and they are talking with each other. Find the length of the string of each phone. So we have to find the length of string of each phone. Ankur is taking one phone, and that string is connected to Sayed. Now Sayed is taking one phone that is connected to David. Okay, so we have to find the string Length, that means we have to find the length AS, we have to find the length DS, or we have to find the length AD. That way only the string is also connected. So basically we have to find the distance between them. Okay. Now since all the distance are same, can we say it's an equilateral triangle? Can we?
Yes, ma'am.
Yes, it's an equilateral triangle, and let's say this is a circle. So obviously there must be a center of the circle. Now we can drop a perpendicular from the center. Okay, let's say this is P. We can drop the perpendicular OP on the chord SD. SD is looking like a chord. So we can say we are dropping a perpendicular on the chord SD. Now there was one theorem that whenever we will be dropping the perpendicular from the center on the chord, that will bisect the chord. So it's an equilateral triangle. Let's say this side is 2x centimeter, 2x unit. This side is 2x unit, and this side is also 2x unit. Why? Because all the distances are same, which is given in the question. Why we are taking 2x? Why not we are taking x? You can also take x. Okay, 2x we are taking so that when the chord is getting bisected, I can say that this is x and this is also x. That's why I have taken 2x just for the convenience, so that easily I can divide. Okay, 2x half part, x and x. Now if you will take x over here, x over there, x over there, then x is getting cutted. That means you will take x by 2 over here, x by 2 over here. Maybe due to the fraction, the calculation will become bit like it will take like a few more steps to do all the calculation. That's why to avoid those calculation, I am taking 2x over here, 2x over there, 2x over here. Now at last we will be getting the value of x. After getting the value of x, we will find 2x because we have to find the distance between them. In the question, it is not written to find the distance between them. In the question, it is written to find the length of the string, but you can understand that string will also be connected like that only, A to S, S to D, D to A. Okay, so basically we have to find the distance between them. Since we are dropping a perpendicular, it is bisecting the chord, so our chord became x and x over here. Now we got one triangle over here. You can see this is one of the triangle OSP. OSP. Okay, here we can write due to by Pythagoras theorem, we can write hypotenuse square is equals to perpendicular square plus base square. SP we know it is x square. OP we don't know what exactly that is. OS we know it is nothing but the radius of the circle, which is given as 20 meters. So we will be writing 20 square. So OP square will be 20 square, that means 400 minus x square. That is OP square. OP will be under root 400 minus x square. Any confusion so far? Is it clear so far?
Yes, ma'am.
Now we will be taking the triangle A, triangle APS, and this is also a right angle triangle. You can see over here I'm talking about triangle APS, which is a right angle triangle, and I'm going to do the same thing. I'm going to take hypotenuse square, that means AS square is equals to the perpendicular square, that means AP square, plus the base square, that means PS square. Okay, the base PS square, we know it is x square. AS, AS we know it is 2x, we have taken 2x whole square, and AP square. So we don't know what is AP. The total AP we don't know. Let's write it as it is. AP square is equals to 2x whole square, that is 4x square, minus x square, that is AP square is 3x square. Now, can I write AP? Can I write AP as a AO plus OP? Can we? Tell me. AP can be written as AO plus OP or not? Can I
Yes,
write
ma'am.
AP as a AO plus OP? Yes, we can. So at the place of AP, I am going to write AO plus OP. AO plus OP. AO plus OP whole square is equals to 3x square. Okay. Now OP we know. We can substitute it over here. AO. AO. Can I say AO is the radius of this circle? AO is also just the radius. Can we? AO
Yes,
is
ma'am.
radius. Do you agree with me? Yes, it's
Yes.
radius. That is 20. So 20 plus OP. OP is under root 400 minus x. That's complete square is equals to 3x square. If we just shift this square to other side, it will become, okay, let's do the squaring only. So we will be having a square, that is 400, plus b square or plus 2ab. So 2 into a into b plus b square, that is 400 minus x, is equals to 3x square. This 400 became 800. This minus x, it's okay, keep it as it is. Plus 20 into 2, 400 minus x is equals to 3x square. Again, we will be doing the square. Let me check by keeping everything on one side. Just a moment. No, let me check. Are we missing anything or what? OP square. AO plus OP is equals to AP. AO, we know it is 20. OP, we have already found OP. If we will do the squaring over here at first, we will be getting AO square plus OP square plus 2 into AO into OP is equals to 3x square, rather than substituting the value at first if we are writing it like this. So AO square, that means 20 square, OP square, that means 400 minus x square, plus 2 times AO, that means 20, OP, that means, okay, so here also we have to take, and if we will do the, if we will shift this square to other side, it will be root 3 into only x, that is AO plus OP. We know AO, 20 plus root 400 minus x is equals to root 3 into only x. Yeah, this is what we will be getting. Okay, and by doing a squaring both side, again we have to continue from here. How we will be doing a squaring both side? We will be having 400 minus x, we will be keeping this one in one side, and we will be having root 3x minus 20 to other side. Okay, let me show you what exactly we did over here. So see, in triangle APS, AS square is equals to AP square plus PS square. Everything is clear so far. Here, just focus on this step. AP square is equals to 3x square, right? So can we write AP is equals to under root 3 times x? Can we? Can we write it? AP is equals to root 3x. Are you there?
Yes, ma'am.
AP is equals to root 3x. That
Yes,
means
ma'am.
AP is equals to root 3 times x. AP means OA plus OP. OP. That is root 3x. Now here we will substitute the value of OP. What is the value of OP we are having? The value of OP we are having under root 400 minus x square. Let's substitute it. Root 400 minus x square. Plus OA we are having 20. We already know root 3x. Now we will be doing squaring both sides. But at first we have to shift this 20 to other side. So root 3 normally x we are having. It is not inside the root. Minus 20 is equals to under root 400 minus x square. Now we will be doing squaring both sides. Here we will be having only 400 minus x square, and here we will be having a minus b whole square pattern. Okay, so root 3x minus 20 whole square. So basically here we will be having a square, that means 3x square, minus 2ab, so minus 2 into 20 into root 3, that is 40 root 3 ab, plus b square, that means plus 400. Here we are having 400 minus x square. 400 over here, 400 over here gone. So basically now we just have to do the calculation. Okay. From here we will be getting the value of x. Here we will be getting 3x square plus x square will be 4x square minus 40 root 3x. Here 0. We can take x common. So we will be having 4x of this 4 and 40 also. A number we can take out common. Let's do that. So we got here 4x square minus 40 root 3 x is equals to 0. X we can take out common from here. 4 and 40 is there. So 4 also we can take out common. So x minus 10 root 3 is equals to 0. So 4x is equals to 0, or x minus 10 root 3 is equals to 0. So x value we got from here as a 10 root 3. And here we got x value as a 0. 0 we cannot take, since we are talking about the side of a triangle, the distance between them. So of course they must be maintaining the distance. They all are not sitting at one point, because it is written they are sitting on boundary having distance between them. So 10 root 3 is the distance between them. Okay, 10 root 3 is not the distance, because we have taken twice x, twice x, twice x. That is the distance. So after finding x value, that is 10 root 3, we have to find twice x. That is 2 into 10 root 3, and 20 root 3 is the distance between each one of them. This became 20 root 3. Now let me summarize the whole thing what we did over here. Okay, so 3 person were there. Let me draw it. 3 students are there who are sitting on the boundary. 1, 2, 3. A, P, S. We have to find the distance between them, that is AP, PS or AS. All are same. So we are saying since all are same, 2x, this one is 2x, this one is 2x, this one is 2x. Now this is a center. So from the center, this is a circle. So obviously there will be center. From the center we are dropping the perpendicular. That perpendicular is bisecting our chord. So total is 2x. This became x. This became x. Okay, here we are getting one triangle, one right angle triangle. I am talking about right angle triangle OP. Oh, this was P or what? OSD. Okay. OSD, and this was P. So the right angle triangle OPS. In this right angle triangle, we are finding OP. Okay, by using Pythagoras theorem. Now in right angle triangle APS, in right angle triangle APS, we are finding AP again by Pythagoras theorem. Okay, we are also finding AP by using triangle APS, the right angle triangle APS. Now AP, OP, this relation we are using. How? We are writing AP is equals to OA plus OP. Okay, we are writing AP is equals to OA plus AP, OA plus OP. OA is nothing but just the radius of this circle, that is 20. AP we have already found, we are substituting in terms of x. OP we have already found, we are substituting in terms of x. We are getting one equation and we are solving that equation. Is it clear to you? Is it clear now? Ifra, Rumasha, is it clear?
Yes,
Okay.
ma'am.
So this is how we can find the distance between them. Okay, in the next class, I'll be taking the next chapter and we will be covering all the important question related to that concept. And yes, today only or in between this, whatever time you are getting before the next class, just do practice all the question from the first chapter and do let me know whether you were able to do that or not. If you are having any confusion, if you are having any doubt, I'll be taking